Welcome to solverfy.
Okay, for number 38, we have kind of a long problem. We're starting off with 1, 2, 3, 4, 5. This pentanal, this aldehyde, we're going to react this with a variety of conditions. I'll try to write a little bit smaller. First, we're using sodium borohydride and methanol. And of course, this is a reducing condition. It can be thought of as an H- source. It's going to attack the carbonyl directly and will generate this primary alcohol. For B, we're using lithium aluminum hydride and then an aqueous workup. Of course, this is also a reducing condition to access this product. C, we're using palladium on carbon with hydrogen gas. And again, this is reducing conditions, so one of these hydrogens can be thought of as an H-, which can add to the carbonyl. The other hydrogen can be thought of as a proton, so all at once you're going to access that. Next, we have some oxidizing condition, PCC, which actually should not oxidize this all the way up to the carboxylic acid. It is supposed to be selective for alcohols up to the aldehyde and should not react any further. Although in practice, sometimes you do see the carboxylic acid. Next, we have a much stronger oxidizing condition under this acidic condition. And in this case, we're definitely going to oxidize all the way up to the carboxylic acid. This was D, this was E. Okay, moving right along. Next we have F with silver oxide and ammonium hydroxide. So this is Tollen's reagent. This is the mirror test because after you react this silver oxide, you'll precipitate out silver solid and you'll see on your glassware this very pretty mirror finish. But this is actually selective for aldehydes and it will oxidize up your aldehydes to your carboxylic acid, but it will not touch, say, alcohols. For G, we have methyl grignard, and then some aqueous workup. Of course, this can be thought of as a nucleophile, which we'll add so that we can access this secondary alcohol. Okay, might have to redraw this. Let's draw it over here. It's taking this aldehyde, reacting it with condition H, which is your phenyllithium. Of course, this just acts as your nucleophile again, so it's going to attack the carbonyl directly. It will generate another secondary alcohol. Okay, for conditioned I, we're using a cuprate, so we have methyl cuprate, which again can be thought of as a nucleophile, which will add directly. And we'll get the same product as previously with a simple methyl addition. HI. For conditions J, we're using this anionic species, which will again attack directly to open up the aldehyde to this alcohol with the alkyne nucleophile added. Okay, let's draw out our starting material one more time. Next we have conditions K, just has an extra methyl on the end, but this organolithium, which is going to act as your nucleophile to attack directly to generate the same product as we've seen. Then lastly, it says the product in A, so that's this product. Let's see if I can, oh, I can just move the screen, how convenient. All right, let's see. This product A with TBDMS chloride and imidazole. Of course, this alcohol is going to do simple substitution to kick out the chloride, and we'll end with this protected ether.